Hello everyone, I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing three-phase semi-converter with RL load. So here, half of the devices are thyristors and half of the devices are diodes. So what we call it as semi-converter. And here we are making use of RL load, and at the same time a freewheeling diode is connected across the load in order to eliminate the negative spike. So here these are the phase voltages and these are the line voltages. I have already explained how to draw these phase voltages and line voltages manually. So here let me not discuss the same here. Refer my previous videos for the detailed explanation of phase voltages as well as line voltages. And here we are providing the triggering pulse for the period of 120 degrees. For the period of 120 degrees. Why is it 120 degrees? Here the total time period of a cycle is 360, and here we are making use of 3 thyristors. That is the reason 360 divided by 3, which is equal to 120 degrees. Each thyristor will be conducting for a period of 120 degrees. And here I am providing the triggering pulse at this instant called alpha is equal to 90. Alpha is equal to 90 in the sense right from 0 crossing itself we need to count. It is because here our by phase is also appeared. And if you see at this instant called 0 crossing, Ry is more positive when compared to that of the by phase. So that is the only reason here we will consider 0 crossing as the reference. And here Ry phase has been appeared and we need to provide the triggering pulse at that instant called alpha is equal to 90. So this is alpha is equal to 30, 60 and 90. So our thyristor will be able to conduct from this instant called alpha is equal to 90. And how long does it conduct? Till this instant called RV. So this is how you need to draw the output voltage waveform for alpha is equal to 90. And even before that, if you see here, because of Ry phase, T1 and D2 will be forward biased. See, this is T1, which is conducting current through the load, and again D2 because of RB phase. Because of RB phase, here thyristor 1 as well as diode 2 will be conducting the current through the load. Alright, so here since RB phase is active at alpha is equal to 90, this is a 0 crossing, alpha is equal to 30, alpha is equal to 60, alpha is equal to 90. Here at this instant called pi by 6 plus alpha, have provided the triggering pulse for the thyristor. R phase in the sense thyristor 1 will be conducting, and B phase in the sense diode 2 will be conducting. Thyristor 1 and diode 2 are conducting during RB phase whenever it is applied to the load. So at that instant, pi from pi plus alpha to 7 pi by 6, RB phase T1 and D2 is conducting, and this is our output voltage waveform for alpha is equal to 90 degrees. And if you see, it will be conducting only when if we provide the triggering pulse. So we are providing the triggering pulse at this instant. Alpha is equal to 90. And how long we need to provide? For 120 degrees, 60, 60, 120 degrees. We need to provide the triggering pulse for each thyristor. So that is the reason here, as long as RB is present, it has conducted. And now Y phase has been appeared. And at this instant, Y phase has been appeared. So this is 0 crossing. Alpha is equal to 30, alpha is equal to 60, and alpha is equal to 90. By the time we have provided the triggering pulse, now YR is being applied across the load. So here it will be conducting right from here. How long it will conduct? As long as YR is present, and by this time P phase has been appeared. So YR output waveform will be, because of YR phase, this is your output voltage, and see YR in the sense Y phase is connected to 3 and R phase in the sense D4 is active. So thyristor is conducting from Y phase T3 load back to D4 and back to supply. So this is the current path during which YR phase is being applied across the load. So now which two devices are active? YR in the sense T3 is active and similarly D4 is active. So this is your output waveform for alpha is equal to 90 when YR is applied across the load. And now again D phase is being appeared and at this instant see here the output voltage is remain 0 until we provide the triggering pulse for the next line voltage. So at this instant it is remain 0 and this is D phase where it is appeared and this is alpha is equal to 30, 60 and 90. From this instant we can provide the triggering pulse for because of BY. So here BY, the output voltage will be following the line voltage BY and BY is being appeared and because of which if you see BY in the sense thyristor 5 load BY. So now because of BY thyristor 5 is conducting and at the same time D6 is also conducting. T5 and D6 is conducting and now again RB that is cycle repeats. So this is the output voltage waveform for alpha is equal to 90. Similarly, let us check out output current waveform. And since we are making use of an inductor, RL load in the sense we have an inductor while supply current, while load current is flowing through the inductor, the polarities across the inductor will be positive, negative. And by the time the positive half cycle is completed, there will be certain amount of energy stored in the inductor and that is given by VL is equal to L into di0 by dt. At the same time, the inductor will be changing, reversing its polarity by the time inductor is completely charged, negative, positive, and it is because inductor does not allow any sudden changes in the current and it tries to maintain the current through the load in the same direction. So that is the reason according to Lenz's law, it reverses its polarities and because of which when compared to these two devices, freewheeling diode will be more forward biased when compared to the other two devices which was conducting. Here freewheeling diode will be more forward biased and whatever the energy stored in the inductor will be fed back to load. So that is the reason here if you see now because of which see from RB phase it is conducting from pi by 6 plus alpha to 7 pi by 6 and from this instant called 7 pi by 6 to 5 pi by 6 plus alpha output current is continuous. It is because of this particular inductor which is feeding energy back to load. So that is the reason here your output current waveform is continuous waveform and it is continuous ripple free. That is because we have considered the very large value of the inductor. So that is the reason here output is continuous and ripple free. This is output current waveform I0 and later current through R phase. Current through R phase in the sense, so here because of current to R phase, see as long as thyristor 1 is conducting, we will get a current through R phase. See R phase in the sense thyristor 1 should be conducting. So that is the reason here we are indicating the supply current of R phase, that is IR, current through R phase. And if you see as long as thyristor 1 is conducting, that is see here it is supposed to conduct. We are triggering the thyristor at 30, 60, 90 degrees. So at this instant R thyristor 1 was triggered and it is conducting, and how long it will conduct till this instant. R phase will be conducting. And by this time, the thyristor is off and freewheeling diode is coming into the picture. So there is no current through the R phase. So that is the reason here at this instant thyristor 1 is getting turned off and it is remaining off. And at this instant YR phase in the sense, see, this is Y. So this is Y phase which is conducting current through the load, and then R phase. And if you see, because of YR phase, thyristor 3 is conducting current through the load and then back to D4, and supply current is getting reversed to that of the first case. So that is the reason here supply current will be reversed. This is due to YR phase and it is remain negative, and this remains 0 as long as thyristor 1 again comes into the conduction state. So at this instant called RB phase, again thyristor 1 is coming into the conduction state. So what? So here what is happening because of RB phase? And if you see RB in the sense, this is thyristor 1 which is conducting current through the load, and then B phase. And if you see, because of this RB phase, current through the supply is positive. That is opposite to that of the previous case. So that is the only reason here supply current will be positive and it will be conducting as long as RB phase is present. So from this instant to this instant, RB phase is conducting and again it is remain 0, and again because of YR phase, the supply current will be negative. Hope you understood why it is positive as well as negative. Supply current is both positive as well as negative. And then when the freewheeling diode is coming into the picture, see here at the instant when we provide the triggering pulse, that is pi by 6 plus alpha to 7 pi by 6, the thyristor is conducting, and at this instant thyristor is getting turned off because freewheeling diode is becoming more positive when compared to the other two devices which were actually conducting. So that is the only reason here now D2 is freewheeling diode is conducting. So at this instant freewheeling diode came into picture, and again here freewheeling diode is conducting current. Whatever the energy stored in the inductor is fed back to load, and again here freewheeling diode is coming into the picture. As long as output voltage is becoming discontinuous or output voltage is remain 0, at this point of time the freewheeling diode is being conducting. So that is the reason supply voltage will not be appeared across the load, because this freewheeling diode will be short circuiting the load voltage. The on-state voltage of the freewheeling diode will be very less. The on-state voltage of the device will be very less, and it will be almost considered as 0. So that is the reason here output voltage is 0, but whereas this is the current which is flowing through the freewheeling diode. Hope you understood this one. And talking about this, I have already explained the phasor diagram for line voltages as well as phase voltages clearly in the previous videos. Please check out that. And average output voltage. V0 average is equal to here 1 by time period. What is the total time period? It is 2 pi by 3. That is, every thyristor will be conducting for a period of 2 pi by 3, and it is actually conducting from pi by 6 plus alpha to 5 pi by 6 plus alpha. Vm sine omega t d omega t. So here 3 Vm by 2 pi, and integration of sine is minus cos within the limits pi by 6 plus alpha to 5 pi by 6 plus alpha, which is equal to 3 root 3 Vm by 2 pi cos alpha. This is V0 average. In the next lecture, we will be seeing three-phase semi-converter with RL load. Thank you.